Hello, how are you doing? Today lecture is about project 5, which is integer errors. Um, see, whenever you go and you try to store information in a database or in a location like a verbal or something, you have a limit. When you go over that limit, that's where it's going to be an integer overflow. It's going to cause a problem. Just like how your picture referred to, with a simple program in a patch file, you can create something like that. So you want to go to sleep, you count from 1 to 100, and guess what? You're going 3,000, 4,000, and you're not sleeping. What's going on? There's something wrong. You should count from 1 to 100, but now you're counting from actually more than that, which is wrong. You know that there's something wrong over here, and let's pull it over here, and you can see that it's keep counting and it's not stopping. So if you decided to count from 1 to 100 and you're to this number, there's something wrong. That's why it's going to be considered an overflow. What we can have even information security, we have an attack called integer overflow attack, which technically try to put information more than what it should handle. And that's actually the page. If you look over here, that example that telling us about integer overflow, they have a reason for that number. Have you ever asked yourself why this number exactly? Because have you ever heard about a 32-bit system? And what's the meaning of a 32-bit system? Have you ever heard about IPv4, that is a 32-bit system, which technically the reason why we are switching from IPv4 to IPv6, that's we are running out of spaces. So technically we need to have more. But why this number? So simple calculation. Let's bring up the calculation. Simple calculation. If you go into a scientific calculation and say 2 to the power of 32, going to give us that exact number. Okay. Now it's 4,294,000,000 and counting, but the 4 is the key over here. That is one of the reasons that a 32-bit system cannot see more than 4 GB of RAM. That's why we needed to change out from a 32-bit system, because we are limited with 4 GB. Same thing over here. This page, if you did not go to it, let's say if we reach 4,294,000 and so on, we are going to have an error. If you actually copy the information from, I don't know if you don't, I see it's cut over here, but if you take the information and copy it and you open the project, you will find the entire text. An example, what the meaning of this. And if you go to this page, they are assuming that the data that's storing the likes for that page going to have an overflow. It may cause an integer overflow because they are assuming that the location or the bit or the place that's storing the like is a 32-bit unsigned integer, which technically when you go more, we will have a problem. So if we go to simple lecture that I provided for you, and I will post it for you as well as a supplement material, what the meaning of an integer overflow. Integer overflow is the condition that occurs when the result of an arithmetic operation, such as multiplication or addition, exceeded the maximum size of an integer used to store it. When an integer overflow occurs, the interrupted value will appear to have wrapped around the maximum value and started again at the minimum value. Similar at when you say you want to represent clock by 1300 or 1 o'clock, it's the same, but it has a limitation. So when you take an 8-bit, and I will tell you why 8-bit. A 32-bit system have 4 locations, right? If I took on IP addresses, a 32-bit system going to have 4 locations to store the IP address or the octet of the IP address, and each bit or each location, each octet is 8 bits. So if you take this 8 bits, you will find that the minimum value is a negative of 128. And a minimum value of negative 128. And the maximum value is 127. So if you take 128 and add it to 127 and put them all together, we are going to have 255, counting the 0, 256. And that's the point over here. When you want to work with IP addresses, you have each octet is a maximum of 255 values. Okay, you cannot go more. Same thing over here. If you take an 8-bit as an integer, you have a negative of 127 and a maximum of 127 and a minimum of 128. So you have this location where you or this place where you can actually put and store information in that integer. Okay, so what's going to happen? Security impact of an integer operation. What's going to happen? Integers or attackers can use these conditions to influence the value of a variable in a way that the programmer did not intend. This is the point. When it comes to a programmer will program based on his programming knowledge. He will not think how attackers will think and try to use what he's doing against him. So when I create a variable that has an 8-bit and I try an attacker come, they will try to overflow that storage with a lot of requests. So attackers can use these conditions to influence the value of a variable in a way that the program did not intend. The security impact depends on the action taken based on the variables. Example include, but not certainly limited to, the following: an integer overflow during a buffer length calculation can result of an allocation of a buffer or allocating a buffer that is too small to hold the data to be copied into. A buffer overflow can result when a data is copied. When calculating a purchase order total, an integer overflow could allow the total to shift from a positive value to a negative value, which is a disaster now because you're losing money over here. This would be in an effect that give money to a customer in addition to their purchases, which technically you lose money. Withdrawing $1 from an account with a balance of 0 could cause an integer underflow and yield a new balance of that amount. A very large positive number in a bank transfer could cause, as a sign of an integer by a back end system, and so on, as we go through of issues. Now, I did bring in C and C++ as an integer overflow because most of the computer programming beginners, they start with an integer overflow programming language with C or C++. And in fact, your project, and I will bring it in a few, work on C++ language. So in a C and C++ programming, integer overflow often occur when calculating the size of a buffer to be allocated. When this occurs, the calculated size of a buffer will be smaller than the amount of the data to be copied into. This can lead to a buffer overflow. Okay. What more? Preventing defects in an integer operation. Preventing defects in an integer operation requires that the software developer anticipate and or respond to these conditions. The best practice for doing so going to be summarized into the two main action. Number one, chooses an integer type. So the programmer should choose what the integer type I need to put in my programming language, what type and what the value of my integer. So choose an integer type used for the variable that is consistent with the function to be performed. In some cases, one can avoid an integer overflow by choosing an integer type that can hold all possible values of a calculation. And all